Hi, my name is Abby Gannon, and this is Kaylee Markham and Trevor Cohair, and we're in the physics class at Belfry High School. So our project was working with a 3D printer, which is something that's kind of new to our school. We've never had a 3D printer until this year, and there was us and then one more group that got to work with this piece of technology this year. And basically, both of our projects involve something that's going to help our community and really advance us as a community, as a small community. So basically, we got the idea from our local pharmacy, and our overall project is to create an abdomen guard for surgery patients who would have to wear a catheter. And so this is basically going to be a more comfortable way for them to be able to live after surgery for the time that they'll be bedridden, so that if they can't get up to use the restroom, then they can, this is going to be more comfortable for them, and it'll just help them a lot more. Next slide. Okay, so basically the guard will attach to their waist, and then a tube will attach into the guard that we print using the 3D printer, and then it will be able to like flow off into a container on the side of the bed. So is basically how it will work. So basically our materials, we use several different programs on the computer to help us work with the technology. And so XYZ Wear and XYZ Scan, along with Tinkercad and Mesh Mixer, are basically the programs that we used in order to help us edit and make our project better and improve our project.
So Tinkercad was the first program that we had ever worked with, and we were really new to it, and it's really basic, and you can just take shapes and edit them to make what you want. And the first thing that we ever printed using Tinkercad was just like a little bowl, because we were just trying to get used to the program. Then we were able to edit the shapes and manipulate them in a way to make it look more like an abdomen guard. And even though we could get like a really rough model, it wasn't really what we wanted. So after that, you can change the slide. So after that, we realized that we needed to just buy an actual abdomen guard to make our models from. You can go to the next slide. And we have two printers. We have one that's just the Da Vinci printer, and then we have a printer and scanner combination. And so we tried to use the scanner in the printer to scan the abdomen guard, but as you can see, it was half, and we couldn't add on to it to make it a full abdomen guard. So we actually have a handheld scanner too, and we had to use that, and we scanned the air dry clay model to get a full scan.
Okay, and so basically how it works is after you get the scan the way that you want it to, you can edit the model that you have made using Mesh Mixer and using Tinkercad. And so we used Mesh Mixer to kind of smooth out the model and make it into the shape that we wanted, and then we downloaded it into Tinkercad, and Tinkercad allowed us to add the hollowed out part underneath and the hole that we put the tubing through. And so we did that in Tinkercad, and then once you get done editing it all that you want, you can download it for 3D printing, and then you put it into the XYZ software, which is where you connect it to the printer and actually print out the shape that you made. And so the next couple slides are just pictures of the different like stages we went through. So you can go on to the next one. So this is like the first one that we made, and it was kind of smaller, and it had a very small hole, and we realized that it needed to be bigger. And so then basically the progression of them, we made them bigger with bigger holes for the tubing, and then we moved the hole around to where we think that it would do the best. And then after we got it into the shape that we wanted, we did some experiments with it. We tried to simulate a person urinating basically by holding the abdomen guard flat and then putting a syringe underneath it through the tubing and seeing if the pressure would be like accurate to go through the abdomen guard and actually come out the other end. And so basically this is our final, will you click on the last slide? The final one that we printed is this one, and then that's the actual one that we printed. And then you just put the tubing through the hole, and that's the one that we conducted our experiments with. So, and now the other group from our school that also works on the 3D printer is going to tell about their project too.
This is 3D casting from Belfry High School. I'm John Luke Carlin, and this is Jared Mueller. Let me switch to the next. The purpose of this project is to build a customized orthotic device using a 3D printer and to help the patient visiting our local pharmacist to get a better deal than what is commercially available on the market. The prototype orthotic devices were created using Autodesk Mesh Mixer and Tinkercad systems and printed with a DaVinci 1.0A 3D printer with ABS filament with a diameter of 1.75. We were also able to scan a cast of the patient's foot and print it via our 3D printer to make a highly durable orthotic brace. The physical parameters, namely density, moment of inertia, and Inks modulus, were obtained by performing displacement, cantilever, and bifilar experiments.
So, as John mentioned before, we use Tinkercad and Autodesk Mesh Mixer in order to create our devices. These programs allow us to model a device in three-dimensional space and really work with the device in order to change it, modify it, and make it really your own until you're happy with the product you have. Tinkercad is a very basic program that allows you to use very basic shapes in order to create different things. But Autodesk Mesh Mixer is a lot more refined. It allows you to really have another layer it makes it a lot easier to create, and it's more refined. Somewhat of my words. It's more refined, and it really allows us to have a more polished, finished product. Again, what we use is a XYZ 3D scanner and a XYZ DaVinci 1.0 A 3D printer. What we do with the scanner is we take and create molds of a patient's foot, and we then scan them. And once we have scanned them, we then take those scans and put them into our Autodesk Mesh Mixer and our Tinkercad software in order to fix it or change it and actually build an entire device around that scan, around the patient's foot, essentially. Once we have come up with a product that we are happy with, we then import the product into our XYZ software, which allows us to change its density, layer height, location on the print bed, orientation. And once we're happy with what we have, we can then print it using our DaVinci 1.0 3D printer.
The quantifying parameters for cast 1 was density, and it was found by using the displacement method. Let me switch to the next slide. The density was found by using mass divided by volume. It was found to be 0.6 grams per cubic centimeter. Moment of inertia was found by the bifilar pendulum method, and what moment of inertia is the tendency of a part of an object to resist change, how stiff it can stay, and that was found to be 6.9 kilograms squared. And the cantilever experiment gives us our weight and weight and displacement ratio. Next slide. The Inks modulus is how much a particular part of the cast can withstand before breaking, and that was found to be 1.3 newtons per meter square on the cast. Next slide. Quantifying parameters for right there. The second cast were done by the same experiments. The density was found to be 628 grams per cubic centimeter, so very close. Same for moment of inertia, 4.64 grams per kilograms per meter squared, and we had the mass, height, width, and length.
So what we really want to do with this project is directly impact back on our community. We're looking to create a more affordable and a lot more comfortable and a better device for children or patients in our area that actually suffer from drop foot or other injuries that allows them to, that does not allow them to move their foot at all. So what this cast does, this is one commercially available right now that we based ours on. This allows you to pick up your foot. It braces on the back of the leg and picks up the bottom of the foot so they don't trip or anything like that. But these are they're hit and miss. It's trial and error trying to get them fitted to the foot, and it's very uncomfortable. So what we're trying to do with our cast is create one that is very comfortable, because it's going to be directly formed to their foot. It's not going to be just a basis for that age group. It's going to be a basis for that patient. And what we're trying to do is also make it a lot cheaper so a lot of people can afford it. That's why we're 3D printing it. And we're just trying to make it to where families in our area can actually have this and be able to benefit from it.
Okay, using our 3D printer, it's possible to build a low-cost customized device for the patient and the community. Parameters determine we can produce a prototype of lightweight and highly durable material. In the near future, we will hopefully be receiving a patient from our local pharmacist, Mr. McNamee. Next slide, please.
I'd like to thank the authorities of the ARI STAR Grant, Mark Gannon, our principal, Tim McNamee, Dr. Kenneth Avery, Miss Bowen, Dr. Rick Golding, and Dr. John Pierce. Any questions? Nobody?